wouldn't it be cool if the Boston Dynamics Spot or any other robot that you might have would be capable of understanding the environment around it with just some brief human interactions, or even better, a description from a human in natural language past the GenAI and have GenAI understand the intent of what Spot needs to do, or the robot that you're carrying. Here you see Spot, it's looking at an electrical panel, and the idea is that one day it would be able to understand what these electrical circuits are, connected to the circuit diagrams and the power calculations that might be in the building. And then now Spot can manage all of that without the human being around it. Here we're telling the Spot what's important and what features to look for. But I can imagine a world very soon where we can create prompts that say, basically find every electrical component, or actually every component within your warehouse, logistics, or health, or even aviation. You think about any use case that might be out there. So to start with, first thing is to understand how to direct Spot manually and give Spot this manual interactions that they can repeat over time. That's called teleoperation. And teleoperation could be semi-autonomous or completely manual, where you can say, I'm going to teleoperate by telling you where to go and what to do, high level, and then have the robot execute on its own. Or it could be completely manual, where, as you can see here, I'm using the Boston Dynamics robot in the distance, the yellow, but then you can see here I am also using the Apple Vision Pro. That's what's on my head. And this user interface was completely built by a program that we have at AWS called Amazon Q for developers. It created this user experience. It created the API interaction using a WebSocket with some guidance from me having a history of working with the Spot, but it read all the documentation itself and then figured out what was important in those documents, and is allowing me now to do things like grab camera images off the camera in real time in about 40-50 frames per second. And now I'm here, moving the Spot around, and you can see the camera is also responding pretty quickly in color. Now, the application that comes with the Boston Dynamics Spot is quite good. It's an Android application, runs on your tablet. You also have a controller. All those things are quite good. I like having both my hands to myself. And on top of that, I like having the ability to access other information. Let's say I had some metrics from my command and control console that I wanted to see, like what's my throughput of my assembly line as Spot's walking through, or other devices. I'd like to be able to go and here, that's me. You can see me live there using my Vision Pro. I like to be able to go through and say, hey, as all this is going on, I want to be able to either let Spot go off on its own and do some automatic processing, or do some manual processing using my hands that I have right there. To come soon in this is a natural language processing, so I should be able to do something like say, hey Spot, meet me in the X room, bathroom, the assembly room, whatever it might be. Meet me over here, or whatever it might be. Go investigate the noise that you heard, or go to level 3 and do a complete survey. And the idea is one day in the future, very soon, you'll be able to put Spot in a room without coding a single thing and have GenAI figure out the code, the coding interface, also figure out the interactions, and surmise what are some of the best next steps for it to do. Definitely not pie in the sky. I think probably the next couple of years, but I'm so excited because the last few years I've been working on this kind of thing, but it's been fairly manual. There hasn't been GenAI. You can see me in the history doing things with various devices, But GenAI is fairly, the last few years has become prevalent. Hi folks, Kamate Richards here again, Senior Strategic Architect from AWS. And I want to talk about AWS GenAI technologies and IoT. You know, as we move toward this concept of embodied AI just in our world, in our lives, we got to think about the baby steps, the crawl before you can walk steps. And many companies have been embarking on this mission by building out robots that are capable of human interactions, minor interactions through reinforcement learning, where we taught the robot how to broadly move and walk in a real world dynamic environment. And we've gotten to the point of having robot foundation models out there in the wild. But how we gather more intelligence and gather more data is to take small baby steps. Code assistance being one of them. We have all of these robots, they're all over the place. They have different manufacturers, different APIs. I'd love to understand how to build out systems dynamically by just pointing large language models at the code and let the code build up more code that we might use one day. What I'm wearing right now is the Apple Vision Pro, and I've built out a small demo, which you've probably seen at the beginning of this movie, and then again at the end, showing the Apple Vision Pro controlling a Boston Dynamics spot through an API that was built mostly, and it's meaning about 80-70% with some coaching by me. And at some point in the future, we'll build out, hopefully, an environment that can just be pointed at a bunch of repos and build out the functionality that you're trying to build out. Let's skip over a few of these slides and just go to the build out slide of this architecture. The architecture that you're seeing in front of you is a combination of some edge-based processing on Python and some Swift front end for the Apple Vision Pro, alongside AWS in the center, which is mainly responsible for orchestrating the interaction between the Boston Dynamics spot and the Apple Vision Pro. Not only is it doing this function, but soon we'll be going even further by allowing the middleware, or the cloud in this case, to control the spot directly using its own logic. We're not quite there yet, but we're working on it. You know, Boston Dynamics Spot's an amazing device. I enjoy using it because it has obstacle avoidance, it has dynamic stability, it has many cameras on board, both depth cameras and for visualization of data. And it's just a perfect form factor. People really enjoy seeing it out in the wild whenever I take it somewhere. People find it to be friendly and not scary, which is always good for a robot. I showed this video a while back. I'm just going to kind of fast forward through the video so you can take a gander of where we started out a few years ago with the Boston Dynamics spot, and this is the Apple Vision Pro. So I'm wearing the Apple Vision Pro here, or actually one of my colleagues is, and you can see the black and white image coming from the Boston Dynamics spot, and here we're getting the data from the user in a tabletop view. So where we are today is a little bit different than we were before. Boston Dynamics Spot is capable of having various payloads. I'm actually designing a payload for the Spot for myself, hopefully to be viewed here in December, and you'll be along the journey with me as I'll be using all my common tools that I always use, the NVIDIA Omniverse, the Autodesk Fusion 360, and ROS, and those kinds of things that I normally use. But what I was trying to accomplish in this particular video is to talk about some of the bottlenecks that I've come across and how I quickly traverse those bottlenecks using LLMs. One thing that really helped me was the ability to write code quickly. What we're seeing here is Amazon Q inside of VS Code. And what's happening here is I'm telling VS Code in natural language basically to execute the next step in sequence that it thinks it should do to make the Spot run. So it read through all the Spot documentation. It found the startup sequence, and I specifically pointed it at a repo called Understanding Spot, and it read through the source code and then all the other code, and then figured out that this is the best way to interact with the Spot. And I had to create a WebSocket service that allows the Spot to interact with the world around it dynamically. Some of the use cases are industrial inspection. Here you see Spot with a high resolution camera, it's a gimbal camera. And then there are other use cases, and you can see Spot walking up and down the stairs and traversing objects. Spot can be left autonomously to work for long periods of time if you utilize the stand that Spot comes with to recharge. Obviously, I'd love to get my hands on one of these. It's Boston Dynamics' newest robot that is a brushless motor-driven robot, a little different than the previous Atlas. Very, very safe, very stable. And here, as you can see, it's in test environment. Can't wait to see it in person. And then you see here Spot with the telescoping arm, and it has a camera now, so it has way more utility. Can open doors, can push buttons to get up and down elevators, etc. But how do you get to these things with just the code that's there? And it's a very extensive API, wonderful, wonderful user experience on the tablet that they have, that the Spot comes with. But it'd be really cool if I can be hands-free. I can operate within my own system, and my user experience would be integrated within other user experiences that I already have. My pie in the sky dream is to one day put my Vision Pro on or some device and walk around my factory or my warehouse and control everything. More like a command and control center. To that end, we have something called AWS IoT Twin Maker and Grafana, and the two of those things together in combination allow you to see the entirety of your digital twin of your warehouse or whatever you may have, all of its metrics, predictive measures if you have them using machine learning, and some services that you might have are either third party or through AWS. We have an AWS marketplace. This is not an AWS ad, but it's very, very useful, highly useful set of tooling. I also use a program called Preview 3D for 3D visualization, and Matterport as well for visualization. Here you can see a visualization that looks like of a space station and the cabin pressure of the space station using Twin Maker and Grafana. Anomaly detection. This is a great use case for not just AWS, but just any kind of use case that you can think of related to healthcare, aviation, automotive. You name the area, and you'll find a use case where you might have some anomalies, and you want to detect that through your data long term. This is not an onboard thing that you would do with the Spot. This is something you would do later. And finally, we get to where we are today in human in the loop. The very interesting point in time that we're at right now is we want to have the Spot actually do things with us involved. I want to walk into a room and have Spot go off and take care of some concerns autonomously, but I also wanted to be able to do that manually. So
Boston Dynamics Spot.
A little bit so you can see how this is going. Powered by video.
Told someone I'd beat him at the dog.
Okay.
Very nice.
The user experience. Quickly generated
and
by Amazon Q. And integrated with X.
Amazon Q has written a user interface for the Boston Dynamics Spot. Here I'm going to tell Spot to stand, and Spot to stand up. Sorry about the fast-moving camera. And then if I want to tell Spot to move,
wrote that from scratch for the Apple Vision Pro. The Apple Vision Pro is what I'm wearing on my head right now. I use it as my primary device for just developer productivity. Right now I have about 8 or 9 windows open telling me what to say. So if I sound more polished than usual, it's because I'm looking at a screen to my right with all of my notes. A little hack that I've picked up. But you can see here the Apple Vision Pro is prime for this kind of interactivity. You can have your hands free. You could be looking in various places. I can touch, tap, and I don't need any kind of peripheral device or handheld device. And now we get to this point of teleoperation and explaining how this happened. The first thing I did was I told Amazon Q to take a look at all the Boston Dynamics documentation, and then from there also take a look at all the Apple Vision Pro documentation, Vision OS, and Reality Kit and others, Swift UI, try to understand what's the best way to communicate between all of these devices. And I did tell it to use a WebSocket because I knew I wanted to do more with WebSockets later on. So here's where we get to. This is that all is very cool, and I think that was a very good start. What we want to get to is actually getting to the point of GenAI controlling the physical world. And so the next step in likely the next video in this series, we'll be talking about the next step in line, which is to take a look at what the robot is seeing, whatever it happens to be looking at, and then making some kind of assumptions or assertions about what to do next as an orchestration layer tool. So that's the next thing we'll be looking at. Look forward to talking to you all soon.
So that's pretty exciting. It pairs up with a Jetson AGX Orin, which is a fantastic mobile compute platform, brings a ton of compute capability at a really modest power level. And then the most importantly, it's paired up and supported by NVIDIA inside of their larger suite of AI development tools, which let you more rapidly produce results. So this is what we're releasing in support of the research community. It's been a long road to here. I think I've asked the question, well, why now? The initial offerings for Spot were really about making a platform other people could build on. We took a foray into building valuable business for industrial customers. And now that we have thousands of robots out and we're really confident about the reliability and the durability and the utility of these things, we're excited to kind of open up the space and let more people develop at a lower level. So speaking of that development, our friends at the Institute, the AI Institute in Boston, took this challenge statement with us, and they were our very first beta customers that we really worked deeply to define what this API should look like. Their researchers helped us set up, a set of requirements for this product, and then they used this very quickly to produce some really compelling results. So this video here is a pixels to motion from scratch behavior that the Institute generated very quickly using this researcher kit. After we release this out to the world, the Institute is going to provide some of this as open source examples to get you started. And hopefully between our three organizations, we'll give the research community something that will help fuel a lot of exciting things going forward. So I'm going to leave you there. Really excited to announce that that work, the stuff we're doing with NVIDIA spans deployment of compute in our platforms, utilization of their tools to drive AI. We're looking at all sorts of exciting things in the future. But today,